Hi and welcome, Statistics 1 students, week 7 of maintenance. Here we go. We've got two questions, both past exam questions, one from the representation of data section of the course and one from probability. Okay, so this first one we've been given some weights in X kilograms of 144 people recorded, and we're popping them in this cumulative frequency table below, and we've got to plot it. So I'm thinking we'll go up in 20s for the cumulative frequency, so 260, 80, 100, 120, 144. And I don't have quite enough available on this graph, but in your sheet it should be fixed. So cumulative frequency. And along the bottom, I guess we could go from 40, 50, 60, 70, 80, 90, 100. Now, we only need to go up to 90. Okay, now just a quick note about how this works. It's actually 40.5 is the class boundary. So I'd plot 0 at 40.5, but on the scale it's basically 40. And then the next class boundary, by the time I'm up to 50, or less than 50, which is the class boundary is 50.5, say, we're up to 12. And each of these little squares going up represents, was it 4, isn't it? Yeah, 4, so this would be 12 here. And then at 60, we've got 34, so 34 would be 28, 32, sort of about there, I think. And then we're 64 by the time we get to 65. Now, 65 or 65.5, which is about here, so 64. Just make sure you're reading this carefully, because I was about to go up to 70, so that point is there. And then less than 70, we're up to 92. So that's 80 plus 12, which is here, that point. And then by the time we get to, well, we go from 70 to 90, and by the time we're at 90, 70, 90, it's 144. Oh, that should be 140 up there, whoops. 144 would just be one square up here, okay? So it sort of goes like this, and try to have a smooth curve. Obviously mine's not looking so super smooth, but that's kind of the rough approximation there. Okay, now let's take a look at what we need to do next. 64 people weigh more than C kilograms. Use your graph to find the value of C. Okay, 64 people weigh more than it. So what you want to do is find, okay, 64, where do we have 64 more people? So if you look at the top, it's 144. So that's, if we just take away 64 from that, that'll get us the point that we need to be at for this. So what's that? 144 minus 64 gives us 80. So we want to go to the 80th person. So we'd go along like this, and there's obviously now 64 above, and then we meet the graph here, and then we go down. Now it's looking to me sort of in the middle of this one here, actually, I think. So to me that's looking like maybe 67. 67. So C equals 67. And I think in this particular case, you would be allowed anywhere between 67 and 68. So we're good there. Now calculate the estimates of the mean and standard deviation of weights. Okay, so what I'm going to do here is I am going to, what am I going to do? I will select, okay, I'm going to do it up the side here. So the mean is easy because what we do is we just use our graph here. So mean, half of 144 is 72. So we go up to the 72nd person. So 60, and then we want to add on 12, so I think that's up here. So our mean should be approximately there, and that to me, excuse the poor drawing, but that to me looks like approximately 66. So I would say mean equals 66. Okay, that would be my mean. Now, what do we do next? That's one way of doing it. Now, are they wanting us to, oh, they say calculate estimates. Okay, so probably they don't want us to read it off the graph. I didn't read the question, did I? Okay, so if they want us to calculate it, what do they want us to do? All right. What they probably want us to do is use the information on the table, which is annoying. Okay, so we want some mid-interval values. So the mid-interval value here is obviously 45. This one 55. This one 62.5. 67.5. And 80. Okay, now so to find the mean, we would do the sum, so mean is equal to the sum of f mid-interval value, or fx, this is an estimate, divide by the frequency. Okay, now let's pop that in. So on the top of our fraction, we're going to have 45 times 12 plus 55 times 34. No, wait, not times 34. Okay, so this is cumulative frequency, so we need to find out what the frequency of each one is. So if this is 12 and then you've gone up to 34, obviously that's going to be 22. And if you've gone from 34 to 64, that must be, what's that, 30, sorry. Okay, and if you're going from 64 to 90, that's like 26, is it? 28. 28. And then if you're going from 92 to 144, that's like 8. Is that 52? I think it's 52. Okay, now, what we then do, so times 12, so 55 times 22 plus 62.5 times 30, so we're just timesing these two values, right, and adding all the way along, plus 67.5 times 80. Ooh, running out of room. Here's what I'm going to do. I'm just going to shove this all along here a bit. And last one times, well, not times, plus 80 times 52. And that should be all over the total frequency, which is 144. Now, if we chuck that into our calculators, what do we get? I'm just going to quickly do that now. And 45 times 12 plus 55 times 22 plus 62.5 times 30 plus 67.5 times 80 plus 80 times 52, all over 144. Now, I'm getting a mean of 90... wait, hang on, divide by... is that all divide by... I'm getting 67.5 or 67.2 kilograms, which, let's face it, was pretty much the estimate that I had before. Okay, perfect. All right, now we also have to work out the standard deviation. Now, remember the formula for the standard deviation. is equal to the square root of the sum of x squared over the frequency, or n, number of items of data, subtract the mean squared. Okay, so what we're going to do, we already know what the mean is. Now I'm going to save my unrounded, go away. I'm going to save my unrounded number. So my unrounded number for this was, I haven't saved it, 67.1875. Okay, so I'm going to say 67.1875. And then, here we go, equals, we're going to put this whole jolly thing here. Now, we got 45 squared times 12 plus 55 squared times 22 plus 62.5 times that's 30 plus 67.5, oh, and I should be squaring those numbers, squared, yep, 67.5 squared times 28 plus 80 squared times 52, and that is all over the 144 minus the mean squared, which is 67.1875 squared. Okay, sorry, that's a real mess. Hopefully it makes some sense to you. Now we chuck this into our calculator. So, and what do we get for our calculated estimate of the standard deviation? 45 squared times 12 plus 55 squared times 22 plus 62.5 squared times 30 plus 67.5 squared times 28 plus 80 squared times 52, and that's all over 144. And then we're going to subtract our mean, 67.1875 squared. Okay. Now, my standard deviation is 11.3. 11.3 to 3 SF. Now, you might be wondering, why is this an estimate? Well, because we're using the mid-interval values as the weight instead of, because we don't know. Let's pick a category. For example, in the category under 50, we know we've got 12 items of data, right? But we don't know where they sit. They're between 40 and 50 of kilograms, right? But we don't know exactly where they are, so we're making an estimate that the average of all of them is 45, and we pretend they're each 45, multiply them by 12, right? So that's why it's an estimate. Okay, I think that's all that we have for that question. Yeah, perfect. Now, what we're going to do is move on to a probability question. So here we have some biscuits. Okay, there are 30 biscuits. That's nice. And they're wrapped in gold foil. I think we can go down there. And some of them are unwrapped. Okay, that's nice. Some of the biscuits are chocolate covered. Good. 12 biscuits are wrapped in gold foil, and of these biscuits, 7 are chocolate coloured. 12 in gold foil, 7 chocolate covered, and 17 chocolate covered biscuits in total. So we've got to fill in this two-way table. Okay, perfect. So, 12 biscuits are wrapped in gold foil, and of them, 7 are chocolate covered. So we're going to go, there's 12 chocolate covered. No, sorry. There's 12 wrapped in gold foil. So this is a 12, and of those, 7 are chocolate coated. And that means 5 are non-chocolate coated. And then we know that there are 17 chocolate covered biscuits in total. So we know that's 17, which means this must be 10. And we know that there are 30 biscuits altogether, which means this must be 18, since 18 plus 12 is 30, which means that this must be 8, which means that this must be 13. So I think we're all done there. That looks pretty straightforward, really. Now, the a biscuit is selected at random from the box. That's nice. Find the probability that the biscuit is wrapped in gold foil. Well, how many are wrapped in gold foil? 12. How many biscuits are there? 30. So we could say 12 over 30, which is indeed 0.4. Okay, so the next one, we are going to look at the biscuit. We return it to the box, and an unwrapped biscuit is selected at random. So we've got to find the probability that the biscuit is chocolate covered. So we're looking at this lot here. There's 18 in total, and we want one that's chocolate covered. So it's 10 out of 18, or what is that? 5 over 9. Okay, or 0.5 recurring. Okay, we return that biscuit to its box. A biscuit is selected at random from the box, and we've got to find the probability that the biscuit is unwrapped given it's chocolate covered. Okay, so this is the old conditional probability scenario here, isn't it? So let's see how we go with this. So we're trying to find the probability that the biscuit is unwrapped given it's chocolate coated. Okay, which is equal to the probability that it is unwrapped and intersection chocolate over the probability that it is chocolate covered. And the probability that it's unwrapped and chocolate covered is this unwrapped and chocolate covered is this one here, 10 out of 30. So 1/3, 10 out of 30 over, and then the probability that's chocolate, what is that? That's altogether there are 12. No, they're not. There are 17 chocolates, aren't there? So that's 17 out of 30. Okay, which if we cancel that, using your division rules, all right? I just remind you of that. 10 over 30 divided by 17 over 30 is the same as 10 over 30 times the reciprocal, right? So we can cancel those out. So that's what I did there. Okay, so that gives us 10 over 17, and I'm pretty happy with that. I think that sounds reasonable. Now the biscuit is returned to the box, and Nasir takes 4 biscuits without replacement from the box, and you've got to find the probability that he takes exactly 2 wrapped biscuits. Okay, so the biscuit is returned to the box. So you know he's got to take wrapped biscuit, unwrapped. Okay, that's what you want. Now, so I guess you could imagine there are a number of different ways that you can arrange these wrapped and unwraps, okay, because you could, move them all around. And I will talk to you about this a little bit more later, but we've got 4 items and 2 of them are the same, so it's 4 choose 2 different ways that you can do it. So if you go on your calculator 4, press the shift button and then the division button will put the C, 4 choose 2, and they'll tell you that there are 6 ways that you can arrange this. I guess we could probably figure this out, couldn't we? You could go W, U, W, U, or you could go W, U, U, W, or you could go U, W, W, U, U, W, U, W. How many you got there? 3, and there must be one more way. Oh, U, U, W, W is the final way we could have it, right? So there's your 6 ways, U, U, W, W. I think that's it. So there's your 6 ways that you can do this. And now you need the probability. So let's go. We'll go all the way up here, right? So there are 6 ways of doing this, and you could have, so we want 2 wrapped. So what's the chance of a wrapped? Well, there are a total of 12 wraps. So it's 12 out of 30 for the first one you pick up. Then it's 11 out of 29 for the second one you pick up, right? And then you need your 2 wraps. So wrapped, it's going to be out of 28 now because you've taken 2 away. Unwrapped. We've done that wrapped. So unwrapped, there starts off as 18, so it's 18. And then the next one, there'll be 17 and only 27 things left. So if we chuck this into our calculators, what do we get? 6 times 12 over 30 times 11 over 29 times 18 over 28 times 17 over 27. 374 over 1075. That would be the exact answer. And to 3 significant figures, we can say it's 0.368. 0.368 to 3 significant figures. Okay, so there we go. We used a bit of the old IG work to help us there. I will talk to you about this, these types of ones that I've done in Part D a bit later on in the course, and you'll be away laughing with those. Alright guys, I hope that's been helpful to you. God bless.